my name is Mariana Sanz and today I'm going to talk about robotics in construction. First of all, I will give an overview about the construction industry and I will do a brief description of the automation in construction over the years. Then I will classify the robotics in construction depending on the intention they were or will be made. Single-task construction robots or integrated robotized construction sites. This is the longest point because there are a few classifications and descriptions of the main functions these robots develop. The next things I will explain are the currently unsolved technical problems with robotics. Finally, I will give some indications about future directions and I will make the conclusions of what we will have seen. This said, let's start with the first point: construction industry description and automation used on it. Construction has been present throughout the history of mankind. It is related to the creation of physical elements in order to satisfy the human needs, especially talking about buildings and where they can develop different activities. A long time ago, construction were very simple because of the few resources they had. New techniques were introduced slowly until we got to where we are today, working with machines that have microprocessors and can make almost every task of the construction process. Research in robots and automation on the construction industry started in the 80s with the introduction of single-purpose robots and continued the following decades. New methods for manipulating information were developed too. These data allowed researchers to improve the quality of robots and their abilities. Depending on this topic, we can distinguish four kinds of construction: commercial, which carries out buildings such as offices; residential, which develops family houses; industrial, which makes factory and similar buildings; and finally, civil construction, the one in charge of getting public structures done. Apart from that, we have the classifications of robotics in construction. First of all, we have the single-task construction robots. Inside of it, we can distinguish other two kinds of applications of robotics in construction: off-site applications and on-site applications. Let's go with off-site applications, which use robotics in component production. Concrete is one of the most consumable materials, so that concrete production is very important. It includes cranes and electric hoists to transport and lift elements. Robots are also used in this production for several assignments, such as cleaning pallets or installing anchors. Brickwork production is also very relevant because of the multiple utilities that bricks have. In this kind of production, automated machines are used to support the laying of bricks, a very hard work for a human. The last important material we are talking about is steel. Automated steel frame production, automated assembling, and automated welding stations are the main robotics used in this kind of production. On the other hand, we have on-site applications, which are the following ones. The first process is steel welding, which consists of making a connection between two parts, trying to achieve the same accuracy as if it was done by a real-life professional. Another one is the reinforcement manufacturing and positioning. It involves cutting and bending rebars, arranging these rebars, and binding and positioning them in certain places. Another important process is the concrete distribution. Only machines are used to distribute concrete panels over large surfaces. These machines can be controlled remotely, teleoperated, sensor-guided, or fully automatic. They can also be truck-mounted, stationary, or mobile, depending on the surface concrete needs to be deposited on. Robots can also be used for customized construction on-site. This requires that the machine has autonomous mobility on the construction site, sensor systems to orientate itself, and automatic pickup and positioning of the bricks. Robotic interior finishing is also a very useful tool to prevent humans at risk from any kind of adversity and to have concrete finishing, tile placement, and frame-proof coating done. Robots have also utility in facade operations. They are crucial in painting and in the inspection and maintenance of gates because they are very precise. They provide better results and they have an almost infallible system to detect failures of damaged parts. Earth moving, road maintenance, and material handling are other kind of processes where robots play an essential role because they require very hazardous tasks which can be difficult or dangerous for humans, and machines can give better results. Now I'm getting into the other kind of construction robots, integrated robotized construction sites. These places imply semi or fully automated processes such as storage, the transport, and the machines used to raise a building. The first one is the robotic roof fill factory approach. Once the foundations have been laid, the equipment is covered with a roof. Then prefabricated parts are assembled in the building, and after that robots deliver and place columns, floors, and other elements of the structure, and finally hydraulic presses push the whole construction to the next story. This process is repeated until the number of stories is the needed one. The second integrated robotized construction site is the robotic field factory on ground approach. The idea is that after the first story is built, hydraulic cylinders push it up one floor at a time and repeat the process until the building is finished. But robotics can also be used in deconstruction. The deconstruction of a building basically consists of reversing the process of construction, story by story. Some elements are used to build other structures, and other elements are recycled. This saves energy and materials. Now let's completely change the direction of the presentation. Let's talk about unsolved technical problems. The first problem is the lack of interoperability between different systems of communication. Information is an essential part of the construction processes, and if it is not available electronically, robots can't use it, consequently leading to a lack of efficiency. The second problem is that the structural connection systems have been designed only for human installations, which leads to the operation of new connections and elements that enable machines to work better with them. The next problem is that tolerance is not always achieved in the real lives, and workers are not responsible of it. The fourth problem is that robots, which need a lot of energy, need to be communicated with supervisory systems. These systems are located far away from the machines, and its communication would cost a lot. It is true that mobile phones have revolutionized the communications, but sometimes it is not enough. The last problem is that measurements needs to be taken in a very precise way and have to be available to everyone. After talking about problems, it is time to talk about future directions. As I said before, the information is a crucial part of the automation, and so that most efforts will have the efficient flow of information as the main goal. Innovation in mobility are also in the spotlight, without forgetting that safety has the position number one in the list of future directions. Well, this presentation is coming to an end, and as a conclusion, we could say that construction nowadays a lot of automated systems, but they have to be improved. At the same time, the new machines will appear with two main goals: perfection and efficiency.